So working on the National Geothermal Data System project really presented a great opportunity to collaborate for us, obviously, with the states of Delaware and Maryland, North Carolina, and Georgia. We worked with many different state agencies and a variety of other individuals and institutions to combine a whole bunch of different data types. In total, over 50,000 data records we were able to identify and add to the National Geothermal Data System. And you can see that most of those records relate to boreholes or wells. They present a great opportunity to see beneath our feet. Especially, you can see Delaware contributed a ton of water wells to this effort. But then we also were able to compile a variety of other data types. And I think that, as many of the other states probably have experienced, a lot of these data, a lot of this information was in paper records. Some of it was rotting in basements, and a lot of it was old archive data. For Virginia, we had some records that went back to the 1800s. Some of our water well ledgers were really old. But we also had to combine this old data with new data from databases that already existed. So this collaborative effort, working with all these different agencies and all these different states, really meant that we were meshing together so many different data sets that really presented quite a bit of a challenge, because even though you might be working within one state, perhaps there are a variety of different agencies within that state that have a similar type of database. So I think this is just a great opportunity to kind of be reminded of what all the different agencies are working on, and to present additional potential opportunities for collaboration in the future. So as we were going through this process, we just kind of kept asking ourselves, well, what can we do with the data? What's going to be done in the future? You know, we've brought together all these records. How are they going to be used by other people, and what could we potentially do to kind of spur on some of these derivative products? And we ended up sitting down with a couple of different representatives from different agencies and industry, and came up with a handful of ideas for derivative products that we thought ultimately would help the industry, would help the research community, and potentially be useful for the public as well. So we decided to start at the beginning, and to me that kind of meant looking at, well, where are our geothermal installations right now? And you know, obviously in the east, geothermal means a whole different thing than it does in the west. But for us, predominantly geothermal meant ground source heat pumps. So we worked with the Virginia State Division of Energy, school systems, and also companies that are installing ground source heat pumps to identify, for Virginia at least, where all the installations are located. And you know, when we produce these derivative tools, we only did this for Virginia, used Virginia as kind of a guinea pig, in the hopes that perhaps the other states that we worked with could produce similar derivative tools in the future based on the data that we combined for the NGDS. So this map is just weighing each county in Virginia based on number of installations, and we already know that there are hundreds of additional installations that exist out there. So for all of these derivative tools, we have, again, this open question of, well, how are we going to add more data in the future? And so all of these derivative map tools really need to be dynamic and hosted somewhere where they can be accessed by other agencies so that they continue to grow into the future. And a tool like this could also be paired with census data such as population density to get a better idea of not only where these installations exist, but perhaps why they exist where they do. So that was our first derivative. Now, for any company that's installing a ground source heat pump, they really want to know where the water is and where the bedrock is. So we worked with Dr. John Costain at Virginia Tech, and he produced a couple different depth to bedrock maps for Virginia, which are hopefully going to be coming out soon in publications. And then we, as the state survey, took on the depth to bedrock. And producing a contour map of depth to bedrock at this scale, at a state scale, is pretty much near impossible just because of the variability. So instead we decided to use point data from our wells that we had compiled for the project. And again, we know there's many more data points out there, especially that exist within the Virginia Department of Transportation. So we hope in the future we can collaborate with them in particular to add to this database. Most of these data points come from the Department of Environmental Quality. We were really excited about using our well data to produce temperature at depth maps, similar to the maps that SMU produced for West Virginia. The only state scale map that we could produce was based on 200-meter below ground surface slice. So this just had to do with the distribution of our wells and how deep they were. So you can kind of see that the coastal plain is much warmer than elsewhere in the state, and that's simply a result of the fact that the elevation is significantly lower in the coastal plain than it is elsewhere. So the red points are from our geothermal wells that are mostly Virginia Tech geothermal project wells, and then the brown points are oil and gas wells, predominantly from Division of Gas and Oil. And if you notice on this slide, there's a greater concentration of wells in southwestern Virginia. That's because this is where our oil and gas fields are. So we thought we could zoom in on southwestern Virginia in particular and produce even more temperature depth slice maps. So we ended up with 13 slices. These, unlike the state map, are based on a sea level datum. And so they are at intervals of 150 meters. And it really gives you a better idea of how temperature changes with depth beneath southwestern Virginia. And these are directly from temperature geophysical logs from oil and gas wells that we have corrected for thermal equilibrium. And then finally, we wanted to produce a baseline heat flow map for Virginia. We had the opportunity to kind of hopefully improve what already existed by using all of these oil and gas wells in southwest Virginia and calculating heat flow values ourselves based on local stratigraphy, local thermal conductivity values taken from samples in the vicinity. And so we ended up with this map. And many of the wells are the same that were used for the temperature at depth slices. And for both of these derivative maps, you can see that there's significant data gaps, especially in central Virginia. So we would love to be able to go back out in the future and kind of either resample these locations that were drilled previously, or drill additional wells to kind of try to start filling in the data gaps. So all of these derivative maps, including all of the data that we submitted to the NGDS, are also available on our State Geological Survey website. And you can see at the bottom where the green arrow is, that's the link to our interactive map server. It's an Esri-based tool, and it allows you to select points, lines, and polygons, extract data in shape files, and there's a pull-up attribute table at the bottom. Pretty much all the attributes that are listed in those tables are identical to those that are in the NGDS. So hopefully this is kind of doubling up on getting the data out there and making it more easily accessible to the public. So in conclusion, I really believe that this whole project has been very positive, a very collaborative effort, and I think for us at least has really increased our awareness of what other agencies are doing, even within our own state, even divisions within our own department. So it's increased interagency awareness. It's also encouraged collaboration in the future, which I think can lead to improved data preservation and also increased efficiency of data collection. Like I said before, there are many different agencies that might be working on very similar projects, but if they paired together, they could put all of their data into one master database that could be useful for multiple agencies. And then I also believe that these preliminary derivative tools that we've produced as an offshoot of the NGDS hopefully have provided or will provide a foundation for the future of the geothermal industry in the East, and perhaps also encourage other states to kind of pick up and produce similar derivative tools. That's it.
All right, thank you, Wendy. I'm going to go ahead and unmute everybody. If you could, if you're not speaking, please mute yourself again. And at this point, I'd like to go ahead and open up a question. Oh, we got some bad echo there. So I will try one more time. Please mute yourself and. Okay. Okay.
Hi, this is Lisa again.
Hi, Lisa.
I really liked your temperature depth maps and your online interactive maps allowing extraction of data. That's great. I just had a question about, I noticed you said, I wasn't sure what the numbers referred to. It was 212 aqueous geochemistry. Is that sites or total analyses, or what is that? It seemed kind of low.
So those are different analyses. They came from multiple different sources, not just from sites. And the aqueous chemistry in general pairs with the springs that we visited ourselves and samples for, or they were analyses from previous research.
Okay, so they're springs. They're not necessarily like county and state water quality from some of your agencies.
No, most of them are direct values from springs themselves.
Okay.
So Wendy, Rick here, did you try to integrate your bottom hole temperature data with the SMU data set, or was that not available at the time?
Yes, we worked with SMU to try to figure out how to do all this. It was a very exciting process, and we did use SMU data. We compared our data set to SMU data. We followed as much methodology as we possibly could from SMU, but we did end up kind of deviating from their methodology in that we used entire geophysical temperature logs rather than simply borehole temperature values, and we did end up calculating heat flow from thermal conductivity and gradient values ourselves. So we ended up with a different but potentially overlapping data set than what SMU had.
Yeah, it looks like you're seeing that high heat flow anomaly to the west that Dave Blackwell has talked about, and looks to be similar to what he's mapped to the west of you.
Yes, we looked at that a lot, and basically came to the conclusion that there isn't enough data, especially in the Giles County area. So you can see the exceptionally high heat flow value kind of in the nook of Virginia, and that's from one geothermal well that Dr. John Costain measured in the 80s, I believe. And we would love to be able to get back out there and take some additional measurements. But yes, you can see a general trend that seems to pair well with the most recent West Virginia SMU map.
Any idea why it's high heat flow there?
Well, we know there are thermal springs in that area. So, initially we thought, well, maybe it just intersects one of the fracture conduits that's transferring high temperature water, except when we look at the temperature profile, at the actual temperature geophysical log, we do not see any spiking of temperature that would indicate, a definite fracture and transfer of water. So it's kind of a little bit confusing. It might have to do with some higher thermal conductivity values, and that's something that we would like to look into in the future, but we've kind of ended up in this place where the best option for us would be to revisit that area and drill a couple additional test wells and take some measurements directly.
Okay.
I'd like to go ahead and move on to our next presenter to try and get us back on time, but thank you, Wendy, very much. I think some of the work that you've done here is really exciting, and what I'll do afterwards is I'll make sure that there's email connections for everybody in case there's additional questions that emerge. So thanks again, Wendy. Appreciate your presentation and all the work that you've done over the last 4 years on this project.
Thank you.